Hello everyone, I hope all of you are doing well. I welcome you all to for my video classes on water harvesting and conservation, and it is a continuation part of video 2. In video 2 we mainly discussed about micro catchment and definition of micro catchment and advantages, limitations. After that we discussed two parameters of design of small water harvesting, and mainly these are the parameters are related to harvesting structures like a bund. So many places we are making water harvesting with help of bund. Here also, if it is for example micro irrigation bund, in that range we are discussing the design parameters. So here we have a design parameter continuation part, right after the calculation of storage capacity. Next point is design of embankment, then providing the seepage control measures, design of sluice gate, design of surplus weir, right. So we'll discuss one by one. First we will discuss design of embankment. So in the design of embankment means, if you take the construction, right, if you are storing the water has to be stored, right. If it is like no, we are constructing bund like this, then water we are storing here, right, water will be stored here. But if you take the cross section, of the bund, the cross section of the bund is looks like this, correct. Cross section of the bund is like no trapezoid. So here top width of the bund, right, and bottom width of the bund, and even height of the bund, and even side slopes of the bund. So here bund slopes will be provided. These are the parameters are considered mainly in this parameter. So we'll see how we are making the design of based on some values or so next is as I told, design of embankment means we have to decide what will be the top width, what will be the bottom width, and what will be the height and side slopes, and which type of material we have to use for the constructions. So each topics will discuss one by one. So here, as I told, these are the rainwater harvesting. So now we are mainly focusing on like how to construct the ponds and percolation tanks. Here we have to construct the bund, but we are not going in detailed design. We are taking some reference values from the empirical values. So here you can see the table. In this table they given three values. One is height of the bund, freeboard of the bund, then top width of the bund. So here we will focus on the how much height we required. So if you are required a height of 2.5 to 4.5 meter, then minimum freeboard you have to provide 0.9 meter, then top width 1.2 meter. So how you are increasing the height of the bund, if it is going more than 7.5 meters, if it is going more than 7.5 meter, then you have to provide the freeboard of 1.8 meter, then top width minimum of 2.7 meter. So here we can get understanding with respect to height, freeboard, and top width. You know what you mean by freeboard. Freeboard has to be provided after the full tank to maximum water level or top bund level. That is the difference between top bund level to full tank level. Next, and how we are deciding the slope also. Here from the empirical values, most of the bund we are maintaining the slope of 2.1 or 2:1, 2 meter horizontal and 1 meter vertical slope commonly used. And if it is a dam height is less, then we are maintain, it is referred to or is suggested to maintain the steep slope comparatively. So then one more parameter, right. So it is stone pitching or stone covers on the upstream bund. So we have a bund. In the bund, like no, upper side of the bund is called as upstream bund and lower side of the bund is called downstream bund. So here when you are storing the water on the upstream, and because of wave creations, because of wind, wave will be created on the water, and due to that wave may it cause the erosion. To prevent the erosion, so we have to provide the stone pitching. So here they are suggesting stone pitching will be provided with the value of 0.3 to 0.6 meter of width based on the requirement. So you will get more understanding with the help of image. If I show the image, it is the only small part of the bund, right. In this bund we can see top bund. Here water is stored up to full tank level, and here one layer of gravel layer, and after the gravel layer stone pitching will be provided. So here you can see it is entirely for stone pitching, and the main purpose of providing the stone pitching is to prevent the erosion of the bund. So that's what we have to provide. So next we will see what are the next considerations of the design of embankment. So next is what kind of material we are using, and based on the material of construction of bund we are classifying mainly three types of bund. So one is homogeneous tank bund. See, by the name only we can understand. So here we are using homogeneous. So homogeneous means what? Homogeneous material we are using for the construction and uniformly. For example, inner dam, outer dam. So all the material is uniform and only one material we are using, and this is called as this kind of tanks are called as homogeneous tank bund. Even you can see in the image, in this image you can see, so homogeneous material. So entire dam is made up of homogeneous, means only one type of material. So next type is, right, next type is zoned tank bund. So by the name also you can remember zone means different types. So here we are not using only one material, we are using 2 to 3 types of material. You can see in the image, right, second image it is, you can see here, here is the I and P. So P indicates pervious material and I indicates impervious materials. So here in the middle they provided impervious material of clay, right? So and clay, gravel, based on the condition and availability on the locality. So between middle portion it is provided impervious and outer portion is provided with the pervious materials. So that's what is called as a zoned tank bund, right? Zoned means different materials, it's not a uniform material. So next we will see one more type is there based on the constructions and based on the material which is available locally. So next type is, right, diaphragm type of bund. So in the diaphragm type of bund is, the difference is only, so in the middle we are constructing some wall, masonry wall in the bund. You can see masonry core wall. The difference is what? Same, it may be used of homogeneous or be used for pervious and pervious, but in the middle to tackle the seepage as well as to give the strength or stability, there is a construction of wall. So you can call masonry wall. So that's what called as diaphragm type of tank bund. So what is the difference? Here we are constructing masonry at the core of the bund, right? So next, yes, next one more very important. We know earthen bund means it has a problem of seepage. So when seepage is there, then it is very difficult to maintain the stability of the bund. To maintain the stability of the bund, it has to tackle the seepage. So we know the seepage, it like passing of water from higher elevation to lower elevation and from one place to another place with help of piping. So if pipings are created on the earthen bund and it causes the stability of the bund, so we have to prevent the seepage. So to prevent the seepage we have mainly two types of seepage control measures. So one is seepage control through the embankment, a seepage control through the bund. So then we have seepage control through the foundation. So even in the foundation, like pipings are created, seepage pipings. So tackle that also, we have to provide the seepage at the bund and seepage at the foundation. So here you can see, and 1, 2, 3 are the methods of seepage control through the embankment. Then 4, 5, 6 are the methods of seepage control through the foundation. No, only 4 and 5 are the seepage control through the foundation. We'll see one by one, right? So first one is rock toy or toe filter. So rock toe or toe filter, you can see here it is like you are call it is a entirely bund. So this part is a upstream area, right, upstream area. So then is a downstream area. So here this portion is called as a heel and this portion is called as, this entire portion is called as toe of the bund. So you can see here seepage or phreatic line is there. So phreatic line is started with the top water level to nearby the toe. So to tackle this phreatic line, why? Because phreatic lines causes the seepage. So here you can see seepage is happening, and to tackle this seepage we have to provide the seepage control measures. So that seepage control measures we are providing at the portion of toe. So it is what called as rock toe. So here we are using the different types of material in the toe portion of the bund. So that's what is called as toe filter or rock toe. So here you can see first layer is a fine sand, next coarse sand, gravel, then rock, and main purpose of providing this kind of layer is to tackle the seepage. So why in this portion? Because from the analysis they got to know that the periodic line is exist in this area, right? So next type is based on the next is horizontal blanket or horizontal filter. So by the name horizontal means all that preventing measures are placed on the horizontal as a blanket. So here also based on the periodic line or seepage line, here you can see the seepage line. So to tackle this seepage line, the blanket will be provided on the horizontal. You can see this horizontal blanket are provided, and main purpose of providing this horizontal blanket is to tackle the seepage, right? So here different layers of materials are there, and first layer is maybe a finer material, and lower one is the coarser material. And what is the difference? So earlier method they provided on the toe portion means like this they provided. So here only horizontal portions has provided. That's what it is called as horizontal blanket or horizontal filter, right? So next last method of seepage control through the embankment, it is chimney drain. So chimney drain means what? We have seen the chimneys in the industries. So we are providing this one chimney means what? Where we are where we are sending the pollutant air to higher elevations. So even we can call it is chimneys, right? So here some impervious wall will be constructed, right? It is a maybe filter material. Even you can see in the diagram here bund is there, and based on the periodic lines, right, here fine material layer is created, and even you can see this portion is called as chimney. And this kind of construction chimney construction is called as a chimney drain, right? So main purpose is to tackle the seepage line. So next method impervious cut offs. So it is a part of seepage control through the foundation. See here also even they are even they are making the concreting of upstream bund, and even they are providing the concrete of at the bottom of the bund, and here also they are providing the concrete. The main purpose of providing the layer of concrete is to prevent the seepage and to impervious cutoff. So why they are called as impervious? Because all the layers are impervious in nature. Maybe it is a masonry or maybe it is a concrete, right? So due to the impervious layer on the upstream slope and at the foundation, and even it is in the foundation, below the foundation and above the impervious foundation. So due to this construction it is called as impervious cutoff, and it is a part of seepage control through the foundation. So next method is relief wells and drainage trenches. So first I use trenches. You can see in the trench in the downstream area. So even you can see it is a pervious layer below the bund, and due to the pervious layer below the bund seepage is happening. You can see the arrows. So arrow shows the flow of water from upstream area to downstream area with the seepage under the foundation, right? So to tackle this foundation seepage they are constructing trench nearby the downstream toe. So here they are collecting the water, and this water has to be collected here, and they has to send away from this, and from this we can tackle the seepage from the foundation. And this method is called drainage trench methods, right? So next is relief well. So similarly same seepage is happening through the foundation. You can see the arrow marks shows the seepage lines, or you can see flow of water from one side to another side, but this has to tackled with relief well. So this well you can see in the downstream area nearby the toe of the bund. So you can see well, right? So due to this construction of well we can remove, you can collect the water, and that called water has to be sent some other places. From this you can maintain less saturated condition in the foundation, and you can get the good stability, and even we are preventing the seepages, right? So next is yes. So I think you understood little about some you understood the highlights of the how to design or how to construct the bund. So now we are dealing with next parameter after the embankment, design of sluice gate. So you know sluice gate, right? Because it is a main parameter. If you are using the water, then how to use the water? It has to have some opening. So to provide the opening to pass the water from stored water to lower area, right? Even you can see in the diagram, color diagram, a colored image, there is a water, then bund is there, right? Here you can see the bund and small two openings are there, right? So why they provided these two openings? Because they want to supply water for irrigation purpose. Don't think about this is a different parameter. This one is surplus weir, so to remove the excess amount of water, but think about only these two openings. So here small two openings are there, here too the mainly they are providing these two openings to use the water for agriculture purpose from stored water to lower area. And you can see the elevation or the location of this sluice gate. So sluice gate is provided above the dead storage, right? Above the dead storage or nearby the bed. So why? Because we are using the water, right? So that's what it has to be placed ground level or above the dead storage, right? And main purpose is to convey the water from stored water to agriculture. And even you can see sluice in a gravity dam, right? So where is the location? At the lower portion. Lower portion means near to the ground level, right? And what is the main purpose of sluice gate? To release the water, or it is a open in a tank bund for releasing stored water into the irrigation channel. I think you understood this, what you mean by sluice gate. And just you have to remember, it is a portion of the bund or part of the bund or part of the structure which releases the water from stored level to lower level of irrigation purpose or any other use. Maybe it is water we are using for canals. So next, based on like no, here they made maybe a classification or what kind of different types of sluice they are using based on the structure. Sluice for small sized tank. So here pipe outlet method, right? I will tell you what you mean by pipe outlet method, but this is a one type of method. This method they are using for small sluice gates, not bigger. If it is small sluice gates means what? Lesser height of the dam, a small dam, earthen dam, right? So here they are using pipe outlets. Pipe outlets means what? They are using the cast iron pipes or cement pipes, cast iron pipe or cement pipe, right, to release the water from stored area to lower area. You can see this arrangement. This entire arrangement is for sluice gate. So here we have to use a wall or opening of wall, and to open the wall there should be some arrangement. So here you can see pipe barrel, right? So here pipe barrel is used to transport from stored area to lower area, right? So even you will get a good imagination if I take the cross section, not cross section, longitudinal section. Even you can see this longitudinal section. Here is a towards the stored area, means upstream area, and this one is a downstream area, right? Cross section. And here wing walls are there, mainly to protect the erosion, right? Wing walls are provided. And here mainly regulations of flow is maintained. And here also a wall will be present, and when you open the wall, water will flow from this lower location to irrigation purpose or some canal, right? This is what arrangement of sluice gate, and it is provided within the bund. And where actually provided? At the ground level or above the dead storage, right? To use the water, mainly to use the water or to release the water to the canal. So next we'll see type of sluice gate. So sluice for medium size of tank. So here I'm using the word medium size of tank, right? So for the medium size of the tank, we are using the sluice gate, and this sluice gate type is called as culvert type of sluice gate. Culvert type of sluice gate. And here minimum size should be maintained. That minimum size is 0.6 meter wide and 0.75 meter height, right? So 0.6 meter wide, then 0.75 meter height, 0.75 meter height, it is a straight. Then it may be provided with the arch or without arch, right? It may be a rectangle or it may be arched, but what is the minimum size? 0.6 into 0.75 meter. And you should not go more than the 4.5 meter per second of velocity when you are releasing full tank level of full water, right? So you can see this is a culvert. So you know what you mean by culvert, right? Many culverts are provided across the drainage of roads, right? Maybe it is the construction of channels with the help of masonry or concrete. So you can see in that bund culvert is provided with some arrangement. So this entire arrangement is to release the water, and mainly it is related to valve to release the water. You can see plug stone. So plug stone means what? They are using plug to, like, no, when they want to release the water, they will open the plug. They want to control the water, then they will close the plug, right? I think you understood this. So next type will go, it is also for medium size of the tank. So first one is small size of tank, and next we studied medium size of the tank, and it is culvert type of sluice. One more medium size of the tank, and it is tower head type sluice. Tower head type sluice. So here, why they called it as a tower type sluice? Because they are constructing tower here. You can see tower means that is just like no intake structure, like a intake structure. This is what entirely regulating the water flow and the platform, and you can see the tower head. So arched culvert, here also they are providing culvert, but it is a arched culvert, and this entire arrangement is provided in upstream, right? So this construction of only this tower head, it is called as tower head type sluice, right? Tower head type sluice, right? So, and this selection of different types are mainly depends on the budget and requirement. Many factors will be there why they are selecting particular type of sluice based on the requirement, right? So next we will go for design of surplus weir. Now we studied embankment design. After the embankment design, we studied about surplus weir, right? Not surplus weir, sluice gate. So now we are going for last portion. Last portion is what? Design of surplus weir. Very important very important part of the bund, and if you are neglecting about this part, it may cause the collapsing of entire bund. Why? Because we don't know what kind of rain will be takes. If high rainfall is there, then more flow towards the tank is there, but we are not removing the excess amount of water from the dam, so then it definitely creates the problem for the bund. So that's what construction of weir is the main portion or main part. So we'll study like no where we are constructing actually the weir, and what you mean by weir. So first we'll understand what you mean by weir. See, I am using the same image. Why? Because in this we have both a sluice as well as weir, correct? So first we'll understand what you mean by weir. So weir means what? You can see in the image, some portion will be provided on the bund or some other place of the bund, not exactly the, you cannot, like no, it not mean that you have to provide on the bund. No, you can provide, but the main purpose is to remove the excess amount of water, to remove excess amount of water. But when we are removing the excess amount of water, when water stored level is increasing from full tank level, when water level in the tank is increasing full tank level, then we have to remove the water. So from where we are removing the water? From escaping weir or tank surplus weir. So even it is called as escape weir and tank surplus weir, right? But, and even one more point is, the water may be stored above the full tank level also. For example, we'll get to know that it is a last rain, so after this rain we may not get the water after this. So thinking in that mind, we are using some stone, like no stone gates. Even you can see in the image, right? Two, you can see this is what it is looking like, a minor dam. Here in the two places water is flowing, muddy water is flowing from upstream to downstream, but you can see some gap, right? So why they are maintaining gap? Because if it is a last rain, they will use the stone gates or some metal gates, and they'll improve the water from the full tank level to maximum water level, right? Maximum water level, right? You can see the white patches. That white patches indicates that is the open portion. Why they maintain the open portion? In future they want to store the water in higher elevation than the full tank level. So I think you understood, right? And one more parameter is, when you are discharging the water from the sluice, sorry, when you are discharging the water from the weir, that weir should discharge the water to the natural drain. So that is the fourth point. Surplus water is carrying down through a natural drainage. When you are releasing the water to the, you should release the water to the natural drainage, right? Not to the canal. So many of the students, they are telling that we can supply the water through the canal. No, canal for it is sluice gate, right? For the natural drainage, it is a surplus weir. So now we'll go for site selection for sluice, right? So we studied the site selection for entire structure, but now we'll mainly focusing on site selection for weir. So first point we'll see, right? So preferable to locate the weir in a natural saddle. So here they're telling that instead of constructing earthen bund where you are getting the barrier naturally. For example, here you constructed the bund, but some portion naturally bund is there, natural barrier is there. So here it is preferred to give the surplus weir. Why? Because it is a escaping of water, means like no, here erosion will be more, erosion force will be there, covering will be there, right? Wear and tear will be there. So to give stability to the structure, where you have a strong portion nearby the bund or periphery of the bund, you have to provide, means a naturally strong place. So next point, exist of well defined escape channel. As I told, when you are removing the water, then after removing water this has to flow well developed channel. So well developed channel means if it is already existing channel, a river or stream is there, towards that only you have to supply the water, right? So where exist channel or channel, where exit channel is there, from there only you have to supply the water to natural drainage. So here the same point, natural drainage, we have to supply the water to natural drainage. So next point is hard foundation reduces the cost of bed production. So for example, why they are using the hard place? Because when you are removing the water, right, in front of, when you are removing, it creates some wear and tear at the depth, right? So when it's creating wear and tear means you have to protect some apron or some concrete bed. So when you don't have the impervious land, then obviously you have to construct impervious bed with concrete or masonry. So to avoid that construction cost, if you are getting the naturally harder place, right, stone, so then it is a good place. So next point is weir may be located on one end of the bund if you are not getting above conditions. If you are not getting like natural saddle, or if you are not getting escaping channels, some conditions means when you are not getting naturally, then you can provide any one side of the bund. It may be right side of the bund or left side of the bund, but we have to provide. Fifth point, surplusing water is likely to be damage culvert area. So when you are releasing the water to the downstream, then from that water should not affect for downstream area, maybe agriculture land. That's what they are telling. When you are releasing the water, that water should not affect the agriculture portion or agriculture or culvert cultivation of the crops. So last point, very important point, first preference is given where natural level is approximately same of full tank level. See, I told when you are getting naturally strong place, right, maybe hill or some part of hill, right, that's called as a geographically strong place, right? Instead of bund means what, it has needs, it has some lesser holding capacity to natural condition. So when you are getting the natural strong place which is same elevation of full tank level, right, so then we can provide on that place weir, right? So next, I think very important site selection, right, and very important part of the bund. So next we'll study different types of the weirs, right? So based on the material and based on the investment and based on the like requirement, we are going for different types of weirs, right? So then mainly three types of weirs are there: masonry weirs, rock fill weirs, concrete weirs. Why they are using the words masonry, rock, concrete? Because same material they are using and same techniques they are using to construct the weir. So we are not going in detailed study how they are designing, just we are going for brief or parameters which we are considering to make the good design. So we'll see one by one. So in the image, first image, and maybe you are getting some confusion. Why? Because it is a cross section, right? If you see the when you see the diagram of weir, when you are taking cross section, right, at some particular place, so then it look like this. See, in this portion it is under the bund, so side of the bund, and after the bund there will be apron or bed, as I told, to remove or to handle the wear and tear or erosion of the bed. here the bed is provided, and this is the bed portion, and it is a nearby bund. And even I told stone, dam stone. So why they will use dam stone? Because they want to improve the water full tank level to maximum water level. Yes, I told in some places they will improve the full tank level to maximum water level with the help of some stones, right? So it is what temporary storage based on the conditions. And it is what masonry type. Why? Because masonry is used. So you can see this stone dam. After the dam stone we have a masonry word. So this entire portion, this portion and this portion is constructed with the masonry. That's what is called as masonry weir, and it is a first type masonry weir with the horizontal floor. It is a first type. It is a first type masonry weir with the horizontal floor, right? So you can see this image. This is the image of example of masonry weir with the horizontal floor, right? Here technique is what? Masonry, and with help of masonry they are constructing the weir, right? Next we'll see masonry weir with the depressed floor. Masonry floor with a depressed 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 floor, right? So here you can see depressed portion is there. Here you can see depression portion is there. So due to this depression portion, it is called as masonry weir with a depressed floor. So next we have masonry weir with stepped floor. Masonry weir with stepped. I think you understood masonry weir with the depressed. So only here we are constructing masonry and here concrete, but depressed floor is there. That's why it is called as masonry weir with the depressed floor. So next type, we'll see next type, right? So in the next type we can see by the name masonry weir with the stepped floor. Masonry weir with the stepped floor. So here also we are using masonry, but here the floor is stepped. The floor is stepped. That's what is called as masonry weir with the stepped floor, right? So next we'll go for rock fill weir. So in the rock fill weir, similarly instead of masonry, you can see this is a masonry, but major portion of the weir is made up of rock fill. So that's what is called as a rock fill weir. So next, last one, concrete weir. Concrete weir. So why it is called as concrete weir? Because on the bund, you can see this is a bund. This entire portion is bund, right? Is a bund filling or earthen filling. In on that we are creating the layer of concrete. Layer of concrete. And due to the application of layer of concrete, it is called as concrete weir, right? So we understood what you mean by weir and the selection for the weir, types of weir, right? I think you understood some highlights about the how to make the design of small earthen water harvesting structures, right? Then thank you for watching this video, right? Thank you so much.